Good morning, good afternoon, and good evening, everyone, based on the time zones you all are coming from. So before we start with the session, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Great. Thank you for confirmation, everyone. So my name is Neeraj Kheria, and I have been working in this IT industry for more than 14 years now. Before we get started, let me just share this Edureka Masterclass community with you all. So this community of masterclasses was started back in 2019, and since then we have been conducted more than 100 webinars in a given month on different topics, including blockchain, IoT, artificial intelligence, block, machine learning, and multiple front-end and back-end development technologies. And the best part about these webinars are they are absolutely free of cost, so there are no charges involved here. And this can be a good platform for anyone who wants to get started in the technology they are interested in. So to be a part of this group, we can click on join this group, and then we would be able to get notified with the entire schedule that has been planned for the month. So we are going to discuss today on Java list, where we are going to specifically discuss on linked list, how linked list is structured in Java and how we can make use of it. So let's get started. So here we are going to discuss on what exactly is a linked list. Then we are going to discuss on types of linked list, the features of linked list, the methods in linked list, and the arrays versus a linked list. And then we are going to have the hands-on as well. So the first thing is what exactly a linked list is. So after arrays, the second most popular data structure is linked list. So we can say a linked list is what? It's simply a linear data structure made of a chain of nodes in which each node contains a value and a pointer to the next node in a given chain. So we can say it's like a collection of multiple nodes where the last link in a linked list points to null, indicating the end of a chain itself. That's how they are structured. And an element in a linked list is called as a node. And the first node itself is called as a head. And then the last node itself is called as the tail itself. So now here's a simple example. For example, let's say we can imagine a linked list like a chain of paper clips that are linked together, and we can easily add other paper clip to the top or the bottom. And it's even quick to insert one in the middle as well. So all you have to do is just to disconnect the chain at the middle and add a new paper clip, and then we can reconnect the other half as a linked list itself available in Java. So we have different type of linked list also available. For example, here we can say here we have the index value as suppose on one we want to store 30, on second block we want to store 30, third block we want to store 40, fourth block we want to store 50, and so on. And then we can simply go ahead and define this as a part of linked list. So linked list is also of multiple types as well. Like we have a single, if we have a singly linked list, we have doubly linked list, or we can say as a bidirectional, and then we have circular linked list as well. So we can combine different elements together. For example, here we have one list containing first, second, third, first, 23rd, 26, 37, 28. So then we have other components. So again, they all can be joined together as a part of the linked list altogether. So here, these are the nodes. And again, this is the tail. This is the head as a value that has been defined. Now, as we discussed, there are multiple types of linked list. First of all, we have the singly linked list, then we have doubly linked list, and then we have circular linked list. So singly is also called as unidirectional, doubly is like a bidirectional, and then we have circular, which is also going to be defined. Now, if we talk about the concept, if we talk about the main singly list here, so basically here we are going to have one head, and then there are going to be multiple nodes being attached here and having the last value as null. And a singly list simply contains two fields, as in the address of the next node and the data assigned to the present node itself. Then if we talk about the second type of list here, like we have doubly linked list that we also call as or we can say bidirectional. So it contains the address of both the address of the next node and address of the previous node as well, along with the data as well. So that is what we refer as the bidirectional, or we can say the second type, which is doubly linked list. And then we have circular linked list, where we have data again available for all for the next node itself. Now, if we talk about features of the linked list, then again, first of all, linked lists simply implements the queue and dequeue interfaces. So therefore, it can be used as a queue, or we can say a dequeue or a stack as well. And then it includes the duplicates. So basically, it can contain all the elements, including duplicates and null. Then we have linked list contains the insertion of order of the elements as well. And then Java linked list class is not synchronized. That means in a multi-threaded environment, we can synchronize concurrent modifications to the linked list externally. And then we can use collections dot synchronize as a simply way to get synchronized linked list as well. And then we have the list iterator, which we can use to iterate the elements of a list as well. And again, our linked list class doesn't implement the random access interface. So we can access the elements in sequential order only. That's how it's going to be. Now, there are multiple methods available in linked list. So first of all, we have to convert the array to a linked list here. Then we have to convert the linked list to arrays. And there are multiple predefined methods that we can make use of. So if we talk about, now before we see this as a part of a hands-on, so we can discuss the main difference between arrays and linked list. So if we talk about arrays, then arrays are not resizable, whereas linked lists are dynamically resizable. There is no fixed structure that we have to follow. We can define the structure that we had to follow. Whereas if we talk about another component, arrays offer more methods, and comparatively few methods are available in linked list because again arrays are more widely used in different programs. Then if we talk about next component, and insertion, addition, and removal operations of an item are faster in arrays, whereas if we compare this to linked list, again they are slower. And then if we talk about the memory consumption, then arrays they consume more memory, whereas linked lists they have a better memory management defined. So now let's look into how exactly we can go ahead and create a linked list where we can see some examples for it. So first of all, what we can do is we can simply go ahead and create a linked list using the linked list class. So for that, we are going to open up our Eclipse. So we can use any IDE if you're comfortable with any, like if you're comfortable with Visual Studio, we can use Visual Studio. If you're comfortable with IntelliJ, you can use IntelliJ. If you're comfortable working with Eclipse, you can use Eclipse, depending upon your own comfort level. Let it open up. All right. So once we open this up, let's do one thing. Let's create a new project altogether. Let's remove this existing one to avoid confusion. We can create a simple Java project. We can name it as demo. We don't want to create a bundle here. Now let's do one thing. We can create a package as well for our use case. We can go ahead and create a package. Let's do that. So here, let's do one thing. Let's say we create a package first. Let's say we can name it as my package. And under this, we can create a class. We can name this one as linked list because we are discussing on linked list itself. Now, in here, we have to import the package as well first. So here we can define import. And then here we are going to import java.util.linked list. And then we also have to import java.util.list iterator. So these two components are the ones that we are going to import. So from Java util, we have to first of all import linked list and then list iterator component. Now, once we have defined, okay, let's do one thing just to avoid the confusion here, because again, linked list must be maybe confused with the class. So we can create a new class altogether. We can name it as linked list example. So here we are going to import from java.util.linked list. and then we are going to import java.util.list iterator. So now we are going to create a simple example for linked list. So here we can define a public method as public static void main. And here, first of all, we are going to declare the linked list. So here we can define linked list for given value for string. And for this string here, we can define, suppose here we can define a simple list element. For example, here we can have L list as simple linked list. And here we can define linked list, and that is for a given string value, a given string. So basically here we are going to declare the linked list, and then we can go ahead and add a string item for adding the items to the linked list here. So we can define L underscore list dot add. Suppose here we want to add the message, suppose as we want to include the word suppose as Python. Then again we can define add list dot add as suppose Java. Then we can define linked list dot add. We want to insert, suppose to say Swift, whatever you want to add, and then we can define system dot out dot println, and here we can define linked list content or items, and then we can concatenate this with L underscore list. So here we can define the current method here. So now we are going to add items at a specific position. So again, we can define linked list dot add. Suppose on second position, we want to add, suppose a JavaScript. We can define for JavaScript. And same way, we want to define a list dot add. On, suppose on fourth position, we want to add, suppose let's say Scala. We can add Scala. So basically what we are doing here, we are simply defining. Let's add this in the same method altogether, not outside it. So here we are simply adding, on second block, we are adding JavaScript. On fourth block, we are adding Scala, and so on. And now we can define system.out.println. And in here, we can define, so linked list after update. And here we can again define linked list. So after these two elements have been added here, so this statement is going to be executed. Same way, if you want to add the first and last items, you want to remove from a position, we want to remove the first and last item, we can do that. For example, after this, so what we can do is we can simply add a comment here. Suppose here we can define, we want to, suppose let's say add items at specific block. So here we have defined this for this one. Again, we can go ahead and add another one. Suppose here we want to add first and last item. So if you want to do that, so again we can use the same concept. So for example, here we define a list dot add first. So add first is also an item available. Suppose here we have first item. We can name it as first item itself, and then we can define again a list dot add last. And here we can define this one as what? As last item. And again, same thing, we can find system dot out dot println, and here we want to print linked list after addition of elements. And here we can simply define same linked list again. So same way we can keep on adding the first and last items. We want to remove the items from a given position. We want to remove the first and last. We can remove that as and when required. For example, we want to remove the items. So for removing the items, we can again simply define it as, let's say, so here again we can define L dot list dot remove, suppose here we want to remove the value stored in the second block that we added here. Now we want to again define, suppose we want to remove, let's say, the first element, the last element. So here we define remove last. So again, the last element which was added here, again, that is going to be removed. And then we can define system.out.println. And here we can define linked list after removing items. So basically, we are performing multiple changes here as and required. And we want to iterate the linked list. Then we can use the iterator as well, depending upon the context, depending upon whatever we want out of it. So for example, now if you want to make use of this one, we can go ahead and run this. So this is going to be executed. So as you can see here, first of all, we have the linked list content as all three content available. Then we have after update. So now we have Python, Java, JavaScript, Swift, Scala. So Scala was added here. I suppose, as you can see here, on second, earlier it was Swift, but now it is JavaScript that we added here. And on fourth, we have defined Scala. Same way, we had removed the item as well. So again, for after here we define first item in the beginning and last item in the end. And then the first item has been removed here. So again, after removing the items, so we had removed the second block. Second block was what? Second block was Java. So as you can see, now Java has been removed. Java has been removed, and then this last element also has been removed, and that's how the list has been displayed. So that's how we can work with the basics of the linked list in terms of updating the content as and when required. So we can discuss another example where we can see how we can convert a linked list to an array. So now if you want to convert this to the array, so what we can do is we can simply import one more package. So here we can define import, and then same from java.util, we are going to import list as well. So now here we have defined suppose here we have multiple core components. For example, let's do one thing. Let's remove everything so that we can avoid having any confusion. All right. So here we can define, suppose, let's say a simple list, and list for a given string value. And for a string, we can define, suppose this one is suppose a simple course list. And here we have a new linked list available. Now, here we are going to define, suppose if here we have course list. So now under course list, we can define, we can add multiple elements. For example, suppose here we add Java. Same way, you can keep on iterating 4 or 5 elements here. Suppose here we have Python, we have Scala, we have JavaScript. So we have multiple languages. Now, once we add them, we can save it. Next is we can define a simple integer. Suppose we can define integer as size, where we can define the course list dot size. So here in this size, we are simply saving the course list size. Course list dot size, and then we can define system dot out dot println, and in here we can define linked list size that we have already defined. And here we can define for string, we are going to find numbers, and here we can define new string, and here we are going to create this for size itself. So we can define size, and then we can define numbers, and within numbers we can define course list dot to array, and by using the parameter as numbers, it's going to be p not v. And then once you define numbers, so again we can define system dot out dot println, and here we can define elements of array are system dot out dot println, and here we can define arrays dot to string, and here we can define for numbers. And since we are going to make use of arrays, so instead of using list iterator because we don't want to use it, so here we can import arrays. So basically here we are going to see the entire output. So let's execute this. So here we have linked list size, and that has been returned as what, 4. And then we have elements, run this up. And then we have elements are same as Java, Python, Scala, and JavaScript that we have created as a part of converting the simple linked list into the array itself. And same way, if you want to convert an array to a linked list, now here we have seen how we can convert the linked list to an array. Same way we can reverse this up as well. Now you want to reverse things up. So for reversing things up, we need to have linked list and let's define. And here we can go ahead and define a complete method. For example, let's remove this up. So here we can define string, and here we may have string for courses defined, where we could have simply define the courses as a part of the array. So here we could have suppose Java, then suppose here we have Python, then here we have suppose let's say same Scala, then we have JavaScript, same thing. So here we can define the arrays as a part of the course as a part of the array, and then we can define list for the given string, and then we can define suppose as course list as new linked list, and then we can define for string as for courses, where we can define we want to use course list dot add. It is going to be course list, not lists, and this one is going to be a simple course list. So here we can define, okay, we want to add the string value. So here, once we add it, we can simply define system.out.println, and here we can define array of courses is, and then we can concatenate this with course list. So here we can now by using this, we can go ahead and convert this into a simple array list. So we can always define that. And we can see it's the same way we have converted this back to, we have defined the array to a simple linked list itself. That's how it works. All right, so that's how we can work with the list components. We can work on deployment of the Wix or the list items. So here we can, if you want, we can even make use of same loop and add methods to convert an array to a linked list. And this way we can save a lot of methods while working with the linked list using the linked list class in Java. And often programmers, they simply confuse the array list properties with the linked list. They both are different. So the both can be implemented by using the list interface. They have different semantics, and based on the requirement, we can choose which one we want to go for. All right. Thank you so much for joining, everyone, and have a great day ahead. Take care. Bye-bye.